Hi, my name is Miyuan Qi, and I work at Intel as a Cloud Edge software lead developer. Today, I want to show you how we are developing Edge-Conductor project, which is an IoT Edge solution based on Kubernetes and cloud-native technologies. Intel Edge-Conductor provides complete end-to-end manageability and infrastructure orchestration for all edge across various IoT verticals, such as retail, healthcare, manufacturing, banking, and entertainment. It is designed and built from ground up using modular software stack focusing on heterogeneous needs of IoT verticals. Edge-Conductor is based on cloud-native technologies. It brings key value adds such as automated onboarding of nodes, security and policy management, and end-to-end lifecycle management of edge infrastructure for IoT use case and can interwork with various Kubernetes distributions. Edge-Conductor is optimized for Intel architecture and leverages the key capabilities of Intel architecture to support the needs of the edge infrastructure. In this demo, I will introduce Edge-Conductor capabilities and how we use it to address IoT edge challenges in terms of deployment difficulties, network complexity, and heterogeneous software and hardware environment in IoT fields. Specifically, I will be demonstrating two use cases. Use case 1. Use Edge-Conductor to deploy an industrial application, defect detection on the wafer, with an image processing pipeline and AI inference framework. Taking advantage of Edge-Conductor's automation features, this application could be deployed to the Edge cluster in the factory as an out-of-box solution. Use case 2. Use Edge-Conductor to onboard super lightweighted IoT devices. For example, industrial controller nodes, Windows hosts for retail, as virtual Kubernetes workers. Many IoT hosts do not have enough resources to meet Kubernetes requirements. Edge-Conductor provides a solution to extend the Kubernetes manageability to these hosts at a minimum cost. The Edge-Conductor starts with a day zero machine. To bring up a cluster from scratch, software components such as the containers images and other artifacts are pulled from upstream repositories to the day zero machine. With the help of Intel Edge Software Provisioner, ESP, the operating system will be installed to the target nodes by Edge-Conductor's OS deploy stat command. Edge-Conductor supports multiple cluster providers, for example, RKE, Cluster API, etc. In this use case, we will use Cluster API to build a Kubernetes cluster on top of target nodes. I use the nodes whose operating systems are already installed in the previous step. Edge-Conductor takes cluster definition as inputs and deploys the cluster by command cluster deploy. Use case 1 requires onboarding a new node in a secure manner by FDO into the cluster. I will show you how Edge-Conductor does this with an automated approach. FDO, short for FIDO Device Onboard, which is an open source project, is the set of services to execute the whole process. These services could be deployed by Edge-Conductor to any of the Kubernetes distributions. Here, I deploy the FDO services to the cluster that I just set up. When a new node connects to the cluster with FDO agent pre-installed, first, the FDO agent communicates with the rendezvous server and identifies itself. Then, the node will be told with the address of the FDO owner services. Next step, the FDO owner services interact with the cluster control plane and send certificates, secrets, and artifacts to the new node. With all the artifacts well prepared, this node will be joining to the Kubernetes cluster. For use case 1, a camera is also required. So I will add an IP camera or a USB camera to the node. Edge-Conductor integrates with Project Acri, which exposes leaf devices like IP cameras, USB cameras, OPCUA devices, etc. as resources in this cluster. Now that the camera is there, any node can use its video stream. In addition, the application requires AI capability to detect defect. So I'm going to add OpenVINO, which is a toolkit for AI and deep learning, and our demo app in the config file. Edge-Conductor deploys both services to the cluster simply by service deploy command. Finally, all set. Here's the use case of defect detection for silicon wafer set up by Edge-Conductor. After running up, the camera starts taking the pictures of the wafer from the manufacturing line. The data going through the image processing pipeline and OpenVINO inference engine is consumed by the demo application and turns to the final defect results. This is about the second use case, onboard super lightweighted IoT devices as virtual Kubernetes workers. I have some Windows PCs and small nodes, like IA or ARM-based industrial control nodes, running Linux in my production environment. And I like these nodes, taking advantage of rich manageability features of Edge-Conductor. However, these nodes could not be pre-provisioned to the standard Kubernetes worker due to the limited system resource or the legacy OS. With Edge-Conductor operator and agent design, we can achieve this goal with a few steps, and this use case will show you how it works. By applying Edge-Conductor's operator to the target cluster, the cluster is now able to manage the underlying nodes in a secure manner. At the node side, Edge-Conductor agent is a lightweight add-on deployed to these nodes to interact with the cluster. Thank you all for joining us in this demonstration of Edge-Conductor capabilities.